Namaste and welcome back. In this learning dialogue video, I'm going to continue with the evolution of grid. In the last video, we had discussed about evolution of grid from the regional grids to the uh, new grid, okay, up to the new grid, where we have all the regions except all the four regions except southern region are interconnected, forming a new grid. Then on 31st December 2013, Southern region was connected to the central grid in the synchronous mode with the commissioning of 765 kV Raichur-Solapur transmission line, thereby achieving one nation, one grid, and one frequency. Okay. So now the entire India is operating with as one nation and one grid and at the same frequency. So whatever the generators that we have, either in Kashmir or Kanyakumari or northern region or southern region or western region or eastern region, all these generators have to run synchronously unless until we have asynchronous grid connections. Okay, but now it's connected. It's a connected network. All these generators has to work the same frequency, making one nation, one grid, one frequency. Okay, this is where we have this is how we have established one nation and one grid. Okay, so for the establishment of this national grid, there was a new transmission line that was built between Karnataka and Maharashtra, and that's planned to push power transmission up to 5,500 megawatts. That means almost 5.5 gigawatts of power can be transferred between these two. Okay, the cost of this system was almost 815 crores, and it was completely borne by the central government, that is Power Grid Corporation. Okay, so with this interconnection, the Indian power system entered into a new era and became one of the largest operating single grids in the world. There is one more milestone. This is one more milestone in the history of a national grid in Indian scenario. Okay, so this is the largest operating synchronous grids in the world with about almost here now it is 370 gigawatts of installed power generation. These numbers are very old. Okay, so synchronous integration of southern grid with the rest of the national grid will not only augment the inter-regional power transfer capacity of the southern region, but also relieve the congestion being experienced in a few transmission corridors. Okay, before this particular transmission line, there is going to be a congestion for the transmission of power from one region to the other region. Okay, that's going to be relieved because of this establishment of this transmission line. And the other advantages are this will be a great boost for further economic growth of the country, and it might take a few more months before power flow in this line was established. Now it is completely established, and now it's operating conditions. Okay, so power star states like Tamil Nadu, Andhra Pradesh, there's a combined Andhra in those days, and Karnataka were waited for the line to be interconnected for them to transmit power purchased from the surplus states in the north and eastern region. Okay, so there are a few surplus states in the northern region and eastern region, and in order to purchase the power from those regions, it has been a neck block for the states like Andhra, Karnataka, and Tamil Nadu. Okay, that was relieved after establishment of this particular transmission line. The line has been connected 5 months ahead of schedule by the Power Grid Corporation. This is one more achievement by the Power Grid Corporation established in the prior to the timelines. So, what are the objectives underlying the formation of national grid? Why do we require national grid? Okay, the answer is simple. It is to transfer power from surplus region to the deficient regions, deficit regions. Okay, what are the power that is surplus in some of the regions that can be transferred to the regions where there is a deficit. Normally, all these regions is western region and southern region. They are power starving. You can say that there is a deficit in power. Okay, so you can transfer from the surplus regions to these regions. Okay, and one more advantage of this national grid is you can utilize maximum resources from the diversified regions. Okay, as we have already discussed, the resource map of India. We have resources at one place and we have loads at the other place. So in order to utilize the resources in an optimal manner, we require this national grid. And also to ensure reliable, economical, and quality power. Okay, when all these are interconnected, then your grid will be more stable because we have more of resources that are available and we have complete monitoring across the network, so it is more reliable. Okay, let us go into the statistics of this transmission network now from the grid. Okay, after forming the grid, let us move on to the transmission network statistics. Okay, when at the time of independence, we used to have 3,708 circuit kilometers of transmission network. Well, a small part of the entire India was having this transmission network. But there is 132 kV and above, more than 2,65,000 circuit kilometers today. Okay, so you can compare the growth of this transmission network over this period from independence to the present day. Okay, so 132 kV and above, we have right now 2,65,000 circuit kilometers. Okay, imagine the length of the transmission network that we have. Okay, Power Grid Company owns and operates about 1,08,128 circuit kilometers of transmission lines at 800 kV DC or 765 kV HVAC and 400 kV, 200 kV, 130 kV HVAC and plus 500 kV HVDC transmission lines. Okay, and 180 with 185 substations at the transmission level. Okay, and the transformation capacity of this entire system is 2 lakh megavolt ampere long back it is in 2014. Okay, so this gigantic transmission network spread over the length and breadth of the country is consistently maintained at an availability of over 99%. Okay, so there are no breakdowns. Okay, it's almost you can say 100% available. So it's 99% time it is available. This entire transmission network. See the challenges for the electrical engineers. Okay, you need to maintain this network without any uh, faults. Okay, so it's a huge and gigantic transmission network. Okay, yes. So Power Grid Corporation launches 12. Okay, these are the initiatives by the Power Grid. Now they are establishing 1200 kV ultra high voltage test station along with the experimental lines in Bina, Madhya Pradesh. Okay, so they are trying to develop these 1200 kV ultra high voltage lines along with the substations. So the investment for the project is estimated to be 800 crores. See the amount of money that we need to invest to develop the infrastructure of the power system. The company is also setting up of a 380 kilometers long 1200 kV transmission line for commercial purpose, which will be constructed between Deoli near Wardha and Aurangabad in Maharashtra. Okay, so these are the initiatives that are taken by this Power Grid Corporation. So till now, the power is transmitted on 765 or 800 kV lines only. Okay, the existing 400 kV line can transfer about 600 megawatts of power. Okay, the existing lines can transfer about power of 600 megawatt power. Okay, coming to the 800 kV line, it's going to be between 1200 megawatt and 2400 megawatt of amount of power that can be transferred when you use 800 kV lines. Now let us consider the 1200 kV line. Okay, so these 1200 kV lines are designed to transfer powers at an amount of 6000 to 8000 megawatts. That means they are designed to transfer 6 to 8 gigawatts of power at a stage. Okay, imagine if there is any fault on such a transmission line. Imagine the situation in the entire grid. And the challenge for it's a challenge for the power system production engineer. Okay, how quickly you need to respond for the faults in such a transmission line. Okay, so these are the challenges for the electrical engineers. Okay? So it's completely dynamic system. It's not a static system. Okay, it's completely dynamic, and you need to clear the faults immediately. Otherwise, if there is any loss of such a transmission line, that's going to be a large burden on the entire system. Okay, that may lead to a blackout for the entire system. Okay, so these are the challenges that are there for the electrical engineers whenever you are designing the systems. Okay. So let us continue the transmission networks in the next video. We will continue with this transmission network establishment zone. Thank you.